Hi and welcome to the Stefan Livera podcast, a show about Bitcoin and Austrian economics. I hope you're all doing well in your corona lockdown, staying safe and hopefully staying healthy. So today for episode 164, if you're interested to learn more about Erlay and Bitcoin Transaction Relay, this is the episode for you. My guest is Gleb Naumenko from Chaincode Labs. This show is brought to you by Kraken, one of the world's leading Bitcoin exchanges. If you haven't signed up yet, why haven't you? Go and check it out, kraken.com. They've got a high-quality platform, they offer high liquidity and high trading volume with low fees. They also offer 24/7 support, so it's really fast and easy to sign up with them. They're consistently rated the best from a security standpoint and also from a user standpoint. Kraken also have Kraken Pro mobile app. Kraken Pro delivers all the security and features you love about the Kraken exchange in a beautiful mobile-first design. Kraken also offer OTC services for those of you who want private, personalized service for large block trades of 100,000 USD or more. Kraken also offer margin up to 5 times, and if you're outside the US, there's also Kraken futures up to 50 times leverage. Go and sign up at kraken.com or find the Kraken Pro mobile app on the Apple App Store or Google Play Store. Next up is Unchained Capital, Bitcoin financial services, and you can secure your keys using their Vault product. If you're bullish on Bitcoin and you expect the Bitcoin price to rise, you want to make sure you've got your security locked down. Unchained make it easy for you with multi-signature vaults. You can use 2 of 3 setup and distribute your keys. You can use Trezor and Ledger, and you can secure your Bitcoin for the long term with that option. Also, friends don't let friends sell Bitcoin. Unchained has a collateralized loan product where you can put up Bitcoin and get USD liquidity. All Bitcoin stored on-chain and it's never rehypothecated, and you can store 1 of the 3 keys in that model. I'm really impressed with Unchained. Go and check them out. They've got an awesome blog, Gradually Then Suddenly, HODL Waves, and they've also got a bunch of open source contributions such as Hermit and Caravan, an open source multi-sig coordinator. Go and learn more at unchained-capital.com. Swan Bitcoin at swanbitcoin.com will help you stack Bitcoin automatically. You want to do it without manual processing. If you're in the US, you must look it up. You can link any major US bank account via ACH and auto buy weekly or monthly. The Bitcoin is delivered to your wallet or stored with a licensed and regulated custodian. I had a recent episode with Corey. A lot of people really enjoyed that episode and understood that Swan Bitcoin's focus is about education and Bitcoin advocacy. They specifically want people to hold their own keys. I'm involved as an advisor with a small equity stake also. So there's givebitcoin.io if you want to gift Bitcoin to people, and then go to swanbitcoin.com for your automated Bitcoin stacking. Here's the interview with Gleb. Gleb, welcome to the show, mate.
Hey, nice to be here.
So Gleb, let's hear a bit about your story. I know you're working at Chaincode Labs, you're working on Erlay and a range of other things as well. Tell us a little bit about yourself and how you got into Bitcoin development.
So I never had a real job. My first job I got on my 3rd year undergrad, started working on Bitcoin exchanges and wallets, stuff like that in Ukraine for 2 years. And then I moved on to do masters in Canada. And that's where my supervisor was like, oh, you're interested in Bitcoin, by just looking at my CV and like, oh, do you want to do something related to that? And that's how we started. And that's Erlay eventually became my master's project.
What was it that got you interested into this whole area, this whole topic of transaction relay?
My supervisor was invited to this conference called Scale in Bitcoin in 2017 in Stanford, but she didn't want to go and she suggested me to go. I was very happy. It's like a free trip. I'll see all the Bitcoin developers. Yeah, I was a hungry student, and yeah, going from Canada to Stanford was quite cool. That was my first time visiting the States. So yeah, I agreed. And when I came, it was like I had no idea about Bitcoin core development or the industry. I thought, so there was this SegWit BCH discussion. I thought SegWit 2x is like SegWit but better. So I thought, why people don't like 2x? I don't understand that. And I was saying, like, I remember talking to Suhas about this at Stanford. But yeah, apart from that, I was sort of inspired. Like it looked so cool. Before going there, I was afraid that Bitcoin core development is like very toxic. Nobody allows new ideas. Nobody welcomes new contributors. But after going there, I was much happier and I wanted to become a contributor too. So when I came back, I started just searching for problems and looking at the software and the protocols, how it works. And it looked like a lot of people looked at attacks on mining or optimizing mining. People worked on wallet. SegWit was obviously a big topic of development at that time, but transaction stuff was like the way peer-to-peer layer was not very well developed at that time. I guess Matt Coralla did a lot. He did compact blocks, which relays blocks in the network much faster, and that's super important. But particularly into transactions, it was something nobody really looked much. So I decided to start there and find a problem, then try to come up with a solution. Yeah.
Yeah, that's an interesting approach. It's that you were looking for other areas, like where's the blue ocean instead of the thing that everybody else is already looking at. So how did you go about learning more about transaction relay within Bitcoin, and how did you come across that problem?
I mean, honestly, for me, it feels like the most interesting part of the code, the way nodes talk to each other, because it's at the same time, it's very high level in a way that I can explain it to whoever, to my brother, to my mom. I can draw on paper arrows between nodes. And at the same time, even though it's very high level, it's like right here, and finding attacks on it is so cool. Like, okay, so what about a bad person does this and that, and now the transaction is censored and just cannot be propagated in the network because somebody sent their own messages. So it's not like 51% attack where somebody sends their transaction by having a lot of hash rate. It just finding a vulnerability in the network protocol and exploiting it. And that felt very cool. So for me, learning it was easy because I just like drawing how things happen on paper and understand that at very high level. Then you look at the code and confirm your observations, maybe write some tests. Yeah, so that was a natural fit to me in a way.
Can you give us just a high level background? How do Bitcoin nodes work now from a transaction lifecycle perspective? Can you just talk us through the basic steps there?
Oh yeah, so imagine you're the best Bitcoin user. So you have your hardware wallet and you have a node which you run at home because you're responsible user. So you sign a transaction on your hardware wallet and you send it from your hardware wallet to the Bitcoin node running at home. Your node will validate it, so it will look at the current blockchain it knows about, check that you're spending the coins that exist, the signature is correct, and then it will announce the transaction by hash to all the peers it is connected to. Your home node usually connected to at least 10 peers, 8 of which used for transaction relay. So it will announce a hash to 8 peers. Just send the hash of a transaction to them. Those guys will look in their local database, and since they don't find the transaction there, they will ask you for the full transaction. This is made for efficiency, so that we don't send transaction body at once and don't waste a lot of bandwidth. That was the first optimization done to this feature, I don't know, more than 5 years ago, I think. So they will ask for a transaction by hash, and then you will send a full transaction. And at that point, the same happens on their side. They validate, check all the rules, they announce to their peers, and that's how transaction gets to miners and eventually appears in a block.
Awesome. And so the Bitcoin network depends on connectivity between the nodes. And so what does that mean? Like, why is that important for the Bitcoin network?
Yeah. So as I said, when you start a node at home, you connect to 10 peers. One could think, why not connect to one? The answer is, if one node is bad, if they want to lie to you, they would be able to do this if your connection is exclusive. So for example, they can double spend you. They can feed you the invalid blockchain, the fake Bitcoin blockchain, where they pretend to pay you. Let's say you accept payments and sell something. So they pretend they paid you, while on the real chain, which is much more difficult to construct and where real miners are, they didn't. So that's effectively a double spend, and they take your good and then they go away without paying you. So to prevent that, we connect to more than one, and the number 8 was chosen randomly, I think, when Satoshi wrote the code.
I guess walking that through that example. So let's say I was malicious and you only connected to me, and I said, "Oh, hey, Gleb, pay me some." What would it be? So basically, it would be I pay you some Bitcoin, and you send me a good, right? Like you're selling me a book, or whatever. And so in that example, I would basically send the transaction to you. Well, I'll send you a block that looks like I've paid you, but in reality, because you don't have enough connections to the outside world and you're only connected through me, then that's where the malicious aspect could come in, and where I would receive, that whatever the physical good was from you or the service from you, and get it for free, because I could then, unbeknownst to you, but to the outside world, actually spend that away back to myself, or just have never spent it to you on the real chain. Is
Yeah.
that roughly what would happen there?
So obviously constructing blocks is expensive. It takes a lot of hash rate. So you would have to, so this is called an Eclipse attack, where you eclipse the victim's view of the network by your malicious fake view. So you start feeding the fake blockchain to the victim. So in order to make this practical, an attacker eclipses the victim from the very beginning, because if they do from the very beginning, they can make the blockchain so that producing blocks is cheap. Imagine just reversing back in time, where blocks were created on Satoshi's computer on a, I don't even know, CPU or graphics card, whatever was used at that time, and just feeding victim just that, like pretending that's entire blockchain, or creating a lot of cheap blocks on top of it without any ASICs, or with one ASIC. So that will make an attack much easier. And then they feed you a block with transaction included in it. So this is just one problem. There are other problems with this called Eclipse attack. They can trivially censor transactions. So if you send transaction to the attacker, try to submit your transaction, they can just drop it on the floor, so it never confirmed the real network. So they can prevent you from transacting. Obviously, you can detect that quite fast, but there are some interesting attacks we will announce soon. We found on Lightning, where in the Lightning network, sometimes it's critical to submit a transaction timely, because there are these time locks and punishment period. So if you're late, you're screwed, and the attacker can steal your funds. So if they can censor you for an hour, that can be already pretty bad. That's the second example of an attack. A third thing I might think of, when somebody is eclipsed, it's very trivial to spy, because if a victim is connected to you exclusively, you see all the messages coming from them, and if you can look also the other nodes in the network, you can notice that some transactions are...
So it might have cut out for a second there, but you were saying that if you were only connected to one person, and then they were able to see all the messages that you were sending, then...
So by looking at the messages coming from a victim, and by looking at the other public nodes in the network, they can notice that some transactions are coming from the victim first. So that would be the victim's transactions, obviously. This is called first spy estimator technique. And that becomes very trivial when there is one connection to the attacker. So it's very easy to map a transaction. So address from address A to address B, X amount of Bitcoin, to map this information to the IP address of the node the transaction is coming from, the victim's node. So an attacker in this case can tell that, this guy in New York at this address just submitted a transaction saying in money to Iran or something, or whatever. Yeah.
And how about now, if we change that example just slightly, what if the user is attempting to use something like a VPN, or they are using Tor, the onion router, to try and mask their traffic? How does it change in that example where you're still only connected to one node?
All right, so it's really different trade-offs. So, for example, in the case of VPN, or in the case of Tor, you're really only protected from your internet provider, so your home ISP. They cannot spy on you. But all these attacks I was talking about, those are my favorite attacks, because they are purely Bitcoin protocol layer. So they work. It's not part of the internet infrastructure. It's just part of the peer-to-peer layer. So you can think that internet infrastructure is underlying, but peer-to-peer layer is sort of on top. And we're attacking peer-to-peer layer. So these things doesn't really help against those. They help against infrastructure attacks, against your government spies on you. So if you're in some Asian country and you're using American VPN, unless they cooperate together, government cannot spy on you if you configured everything securely. So these are really different things.
Yeah. Yeah, just wanted to clarify that and make it clear that these are in some ways different things. And so it's different things to mitigate against other, different components that mitigate against different attacks, let's say. And so I guess the underlying lesson or message there is that even if you are using some of these anonymization or pseudonymous techniques like using a VPN or using Tor, it's still important that you are connected to multiple different nodes such that you aren't only doxing or only giving a transaction through one specific node, because then they can start to infer things from you about who you are or what you're transacting on the Bitcoin network, right?
Yes, so there is another interesting trade-off. This is like, nobody really talks about this, but connecting to too many nodes is also bad because you don't want everybody in the network to hear from you either. So we should find this sweet spot. Like, I would say from 8 to, I don't know, maybe 30 nodes is something reasonable, because, like, just to be clear, there are 10,000 reachable nodes in the network. So 10,000 nodes which run publicly and can be accessible from any part of the world, you can connect to them. So out of that 10,000, we choose like at least 8. And I think that's a reasonable bound, because if you connect to everybody, all of them, and everybody connects to all of them, you become susceptible to other things.
Right. And as I understand, that's also one of the... So there's that concept of the spy node that tries to aggressively connect to every possible node, and then using that to try to identify where on the network a transaction originated from based on the timings and where it first saw it. And then that was the thing that the idea of Dandelion was born to try and counter against that. Now, as I understand, Dandelion has some other trade-offs that hasn't quite made it into Bitcoin Core yet. Could you just spell out a little bit around that and the thinking on that?
Yeah, so we were talking about Eclipse attacks before, where somebody owns your blockchain view or your connection effectively to the network. This is some other research area, which is basically, we can call it transaction origin inference attack. So to find out where transaction is coming from, what's the first node to have some transaction, because then you can de-anonymize people. So yes, you're exactly right. The most obvious and the most easy approach is to connect to everybody, for an attacker to connect to everybody and try to observe messages and try to infer do timing analysis, see at what time the messages are coming from first. That's the most widely used and discussed approach. So Dandelion was this research idea first, and then it was actually proposed as a PR. Per Dandelion, instead of relaying a transaction to everybody, as I explained, which is called flooding, because you send to everybody you have 8 connections, you send to all of them. In Dandelion, first you send to just one random node out of 8, and that random node sends to one node again, so that there is this, on average, 10 hops. They call it stem phase, like in a dandelion, like in a flower. 10 hops stem, and after those 10 hops, at the 10th node, it starts to flood. That's why for the spy, using the same technique, it will probably look like that 10th node is the source of the transaction, which is obviously wrong. So that's how, at the high level, it is supposed to work. The problem with Dandelion is that there is this trade-off. So far, the problem is we can either make it less effective so that an attacker can find an easy way to hijack it, to prevent it from working, to de-anonymize stuff Dandelion is used for, or it will require too many resources a node will consume. So a node will have to spend much more extra RAM, memory, and maybe bandwidth too. So because Dandelion is not it's not even a perfect solution. It's only an attempt. It's called like a heuristic, an attempt to make something more private without really good proven guarantees. This trade-off was never in favor of Dandelion. So we're still open to try to make it possible, but so far we spent Bitcoin Core developers spent a bit of time trying to make it happen, and this trade-off becomes more and more clear and challenging, so that we are now looking at probably other solutions to this problem.
And so bringing it back then to Erlay and transaction relay just in general. So the Bitcoin network has this INV message flooding, and that could be explained as being high fault tolerance, but poor bandwidth efficiency. So what is fault tolerance there?
So INV, it stands for inventory or inventory inv. So this is this hash announcement I explained. You see a transaction, you first announce it by hash to your peers. It is high fault tolerant because you announce it to all peers you know. So it's like the best efforts. You don't trust a single peer with Erlay in your transaction. You send to everybody. So that's why it's high fault tolerant. At the same time, because everybody receives it, probably not and they do the same. Everybody receives it 8 times if you think, because you have 8 peers and you send to them, and imagine the first peer sends to some far peer in South America, and South American peer sends to the second peer you already sent to. So that guy at that point receives it second time, like the same hash, which is not necessary, and that's why it is high fault tolerant, but it spends a lot of bandwidth. Everybody receives everything 8 times.
Yeah, and so it just becomes a very costly from a network perspective. Would that be fair to say, as the network grows, right?
So there are 2 aspects to this. First, every node spends a bit like the most conservative full node, which release transactions, spends 30 gig of bandwidth a month, which is, I guess, all right for Western countries, but if you're on mobile internet or if you're in developing markets or elsewhere, it can be problematic. So out of those 30 gigabytes, half of them is just this hash announcements, 90% of which is duplicate. So I got a hash for this transaction, and I will get it from my other peer too for the second time. So all those duplicates constitute effectively almost half of the bandwidth a node spends. Ideally, we could get rid of them.
I see. And then, so I guess this is where Erlay comes in. What are some of the, what can you just give us a high level? What is Erlay and what are some of the benefits of it?
Yeah, so Erlay is a way to relay transactions without sending those hashes to everybody. Instead of this, you get a transaction, you will forward it to only a subset of your peers, not to 8 or not to all of them, because you also have inbound peers. Maybe if you're running a reachable node, you have 8 outbound, 8 to 10, depends on which patch you're running, and you have inbound peers. So you will send only to outbound, and with inbound, you will not send it to them by hash, but you will do very efficient mathematic encoding thing to exchange your transactions with them, so that it's much more efficient. You're not announcing everything by hash right away. You're constructing this, we call it sketch, of all you have, and send it to them, and they will try to look at that sketch and try to see what exactly their local view is missing, and request only what's needed. So that's effectively how Erlay works. And 2 main achievements is that you remember that 30 gig of bandwidth a month. With Erlay, it will be only 18 instead of 30. That's first achievement. The second one is before Erlay, since you're relaying your announcements through all connections you have, it poorly scales with the original protocol, poorly scales with connectivity. So if you want to increase connections from 8 to 16, you will spend twice as much bandwidth, and meaning that instead of 30 gig of bandwidth a month, you will spend 45, because it used to be 15 for infs and 15 for everything else. Now it's 30 for infs and 15 for everything else, 45 in total. With Erlay, the cost, if you increase connections from 8 to 16, will remain almost the same. So instead of 18, you will spend 19 gig a month, which is super cool. And we want to increase connectivity, as we explained in the beginning. Connectivity gives you high fault tolerance, meaning more security. You rely less on those 8 connections you have, because if you have 16 now, maybe 15 can be bad, but if 16 is good, you're fine.
Gotcha. And then in terms of the costs, as I understand, it will slow down the propagation speed of a transaction. So can you just outline a little bit around what that cost would be?
Yeah, so once you send your transaction from your mobile wallet to your local node, it will take right now almost a bit less than 4 seconds to send it to every node in the network. So in 4 seconds, every node will know about your transaction, assuming it is valid. And yeah.
And so how would that change in the Erlay model?
Yeah. So 4 seconds is primarily, it's not because internet is slow. If because of the internet, the speed is just like less than a second, but we add some artificial delay to add more randomness to the process of relaying, so that the observations the spy is making is worse. There is some noise. So let's say your node got a transaction, and instead of relaying it right away, you will wait some random time within 2 seconds before you're relaying it forward. So that's where 4 seconds is coming from. It's not just internet. It's also our Bitcoin layer on purpose delay for protection, for privacy protection. And with Erlay, it will take, instead of 4 seconds, it will take almost 6, according to the experiments I made, and according, to different measurements I took. And what it really means in a broader context, we believe this is totally fine, because usually what matters for a payment receiver or whoever will be looking for a transaction is to they will probably want at least one confirmation in the blockchain, and one block takes 10 minutes. So that 2 seconds difference in the context of 10 minutes is not a big deal, we believe. That's why we accepted this latency increase. It's possible to make Erlay 4 seconds or even less, but it probably won't be as efficient. It will cost a little more bandwidth, so we took this trade-off.
Yep, I see. And just for clarity for listeners, I guess it's when you've broadcast the transaction, but it is not yet confirmed. It's it's sitting there in the mempool and so on. What you're talking about here, Gleb, is saying that transaction you might not see it in your mempool for the 6 seconds. That's how to understand it, right?
Yes, totally.
So can you just tell us a little bit about some of the new messages and what's needed to make this work, right? So in the past it was INV and then GetTX, and now you're introducing a few more messages into the protocol, and that's how this reconciliation protocol works, right?
Yes. So reconciliation is this process of efficient comparing sets. It's really just 2 different sets of numbers, and we think instead of just numbers, we use transaction IDs, which stand for, it's transaction hash but shortened. We made it short because that's an easy way to save a bit bandwidth right away, just because transaction hashes are too long for no real reason. In this case, they can be shorter because the attack surface is not that it's still difficult to fake them. And second, this reconciliation processes efficient set comparison is very intensive math, so it better operates over small numbers. So let's first I think it's more interesting, try to explain what happens under the hood. Let's say you have 10 transactions and I have 10 transactions, and 9 of them are same, but you have 1 new transaction and I have 1 new transaction, and they're different. So let's say the ID of your new transaction is 11 and ID of my new transaction is 12. What's the how many numbers like that, like let's say of the order of 100, we should send to help each other to find the missing transactions? And the obvious approach to this is you send me all your numbers, so all your IDs, like 1, 2, 3, 4 up to 11. I look at them, I remove what I already know, and I send you back the one you're missing. But the cost of that would be what? Transmitting 12 messages, right? So you send me all yours, well, 11 or something, and I send you one back. With this efficient reconciliation math, which is based on, ironically, something called BCH codes. Yeah, it's the library mini sketch we wrote with Peter and Greg to make this math work. With this math, we can exchange this missing transaction, send in just 2 numbers, and that's super. Like, you almost theoretically not possible to do better than just send it 2 numbers. It's almost, imagine you got lucky. So I found out randomly out of my 10 transactions which one you're missing and send it to you, and you send to me what you found you're lucky to find. But there is math we found which makes this possible without guessing, with almost 100% chance of success. So all the protocol messages, all the new protocol messages introduced are basically to facilitate exchanging of those. So we use sketches for that. So you take your list of transactions or transaction IDs and you compute a sketch of them. So you compute a shortened representation of them, like very compressed. And just basically sending those sketches back and forth is what I introduced. There are, I think, 5 new messages on the P2P layer, so it's quite a lot. We had probably 20 before, and after this there will be 25. But I think it's not a big deal because it's like just, it's not really limited.
Yep. And in terms of changes to the Bitcoin, to Bitcoin Core, this would not be considered a consensus change, right? So it's not that it needs like some big soft fork and so on, right? It's something that can be implemented without like that level of kind of community adoption or whatever. Can you tell us a little bit about that process, though, in terms of what stage the proposal is at and so on, and other feedback and so on?
Yeah. Yes, it sort of doesn't need any hard forks or soft forks. I'm running it right now with my nodes. So I have 9 like front, like avant-garde nodes, which talk to external world but support Erlay, but don't do Erlay with external world. And I have 1 node which purely talks just Erlay to those 10. So, and I'm just looking at how efficient in terms of bandwidth is that one, and I'm just confirming all the measurements I had before with that. So it works today. It will get better. It scales better with the adoption. So the more reachable nodes run it, the better it is for everyone, more efficient. But you will see improvements if at least one of your peers are running Erlay. It's already going to be better than before. Yeah. In terms of the process, I mean, I think I did my best to make it happen. I gave a lot of talks on it. I wrote a lot of analysis. I published code a month ago. We got some initial attention, but right now there is some slowdown, maybe because of coronavirus, maybe because my code is based on some changes which are not yet adopted. So Suhas suggested to use, it's very technical thing, suggested to use WTX ID, so witness transaction IDs, which include witness thing where you compute the transaction ID, which should have happened right after SegWit, but nobody really bothered. So my changes right now are based on those. Just when you're announcing a transaction, you're not announcing by plain ID, but announce the ID, which includes the witness. And yeah, I hope that once that is merged, which seems to be very soon, like I hope it gets merged in April. Then after that, I hope there will be more attention to the code review, or I'll just start nudging people, and yeah.
Yeah, I think from a recent Socratic seminar, I think there was a pull request by Suhas in relation to the witness TXID. Would you mind just explaining a little bit around? So, most of us in the Bitcoin world, we're used to searching a TXID, a transaction ID. Could you just spell out what the differences are between, say, the transaction ID and the witness transaction ID, and then what you're talking about for Erlay, which is a short transaction ID?
Oh yeah, witness transaction ID is not really very different. It's just so transaction ID is always a hash. You take all the content of your transaction, like source, destination, amount. Well, it's very simplistic terms, but yeah, and you hash them. And hash is really a compression. So you take some data and you make a much smaller data out of it, and that's small enough to use it as an identifier, the one you can read, you can compare. And we used to in the I'm not even sure what blockchain explorers are currently using. They're probably using WTX IDs for post SegBit transactions, because those are not malleable, or uh, yeah, there are, I guess they're using WTX IDs. And but this is specifically a PR related to peer-to-peer, how nodes talk to each other. People don't care about that. You can only see it if you look at your logs. So yes, so that's the difference between the two. And in Erlay, we just take, well, because we decided to base it on Suhas's PR. To compute a short ID, we just take the WTX ID and cut it in. Oh, well, actually not. It's not that simple. We make it a little shorter, and then we use some salting technique. Salt is where you add something to the initial data to make hash different for every connection, so that if somebody can grind two different transactions which map to the same short ID, they cannot attack the system. This is called a collision, when somebody can find data which commits to the same hash. So to prevent that, the common technique is salt, to add some static data to the initial one, so that an attacker, it's very difficult to grind them for every connection, because every connection will have different short ID. So yeah, it's very technical. Erlay just makes this little thing. Again, the goal was to cut some bandwidth basically for free, because it's easy, just to make transaction identifiers used smaller, and to allow efficient math to work faster.
Cool. And so the hope then is that once that WTX ID PR is merged into Bitcoin Core, then you're hoping for some additional review and getting Erlay merged into Bitcoin Core, and then it would just be in future version of Bitcoin Core. Could you just also spell out how it would work between the nodes that don't support Erlay yet? Would it just be some kind of version signaling and saying, oh no, I can't speak Erlay, you need to speak the old language with me?
Well, yeah. Erlay node will simply, the first thing it will send, it will see that it will try to establish a Erlay reconciliation protocol. Like, it will just send, I want to talk to you in Erlay. And if the node doesn't respond, then the new node will fall back to the existing protocol. That's how we do similar thing. That's how we will do WTX82. It's like the new node will ask the counterparty, can you talk WTX-AD for relay? And if they never respond, it will use the old ones. And the same we do for compact blocks. It's a very efficient protocol to relay blocks across the network. It's the same thing. It's how we negotiate features. Yeah.
Awesome. And so listeners, if you haven't already, I recommend checking out the episode Matt Corallo on the Chaincode podcast, where he spoke about that in a bit more detail around how compact blocks and fiber and so on, some of these things work. So that's good info there. So look, I guess that's kind of the Erlay stuff. Let's talk a bit more broadly around Bitcoin. Do you have any other things that you see that you would like to see improvement on in terms of Bitcoin Core code base? or are there any other things that you're thinking about in terms of like security or performance?
Yes, there are several topics I've been trying to push forward slowly for a bit, but I think it just takes, like, there should be a leader. With these features, it's often like there should be, somebody who just talks about this over and over again. And I want to get done with Erlay and then just start with a new big feature. In the meantime, I'm just focusing on small things. I have a PR to make address relay better. So IP address, every node, every day, every node will announce their own IP address to the network so that we know about each other. So that if the connection is dropped, we can connect to somebody else. So that feature that's a little broken right now because of we relay to addresses to the nodes which will never relay forward, namely SPV clients. Because SPV clients are limited, they won't obviously relay. They don't care about your IP address, but we'll still send to them. And because of that, it's a bit broken because it relays slower than expected across the network. I'm looking at how to make like network privacy a bit better, how to protect privacy leak in terms of when a new node starts, how to talk last to the DNS server, which helps you to find out about the new nodes. Every time you start a new node, fresh node, you first learn your peers from the DNS seed. And I recently suggested a change how to talk to them less, so that part of internet infrastructure doesn't learn about new nodes that easily. The topics I'm gonna be looking at probably maybe with denial of service protection. So right now there are ways to just exhaust all the resources of a victim node. If you're running like on a reachable IP address, I can probably just make your node working much more slowly remotely, or just like exhaust your CPU or RAM. So I'm gonna start looking into that and suggest some fundamental change to make it better. There are good protections right now, but some of them are just not really effective, and there should be a big solution to that. So basically, to protect nodes from being exhausted by malicious actors.
Right, and I've heard historically, and maybe this is still true, that it's possible to craft these like malicious blocks and so on that will basically chew up the resources of the node that receives it.
Yeah, that there was a really great discussion a month or two ago on different Socratic seminars, and there was a suggestion from Bitcoin guys from Purse.io. It's in implementation of Bitcoin is JavaScript. They really went through this problem with constructing fake blocks, and so there is developments on that side, but there is like a really fundamental way how to solve the issue with denial of services. I want to try to make it happen and see how difficult it is.
And looking more now at the application level of Bitcoin applications, things like wallets and so on, are there any things that you see there that what's your sense there? Are there things that what's most needed?
Oh, I'm just getting excited. I opened my first PR to Rust Lightning just an hour ago. It's work in progress, but I just started writing tests to understand the code base. I'm probably like, so at Chaincode Labs, so since summer, it was me and Antoine Riard, and we tried to combine my knowledge of Bitcoin peer-to-peer and his knowledge of Lightning stuff together, and we found mostly him. He finds some attack, and then I'm trying to look deep into it, to look how much does it cost to actually execute it, to think about like how to deviate, how to protect from it. He also takes part in that too. So I'm just now slowly migrating to Lightning, it seems, to Lightning protocol development, to Lightning infrastructure stuff. We'll see how that works out at the end, but but that's it seems like that's where I'm moving. I hope the issues with Bitcoin will be over soon. I really hope in 2 years I will resolve all my to-do list about Bitcoin vulnerabilities on the peer-to-peer layer. They're not that big, but they're still like privacy leaks here and there, small things, especially with the address relay with the IP, because you can track how those messages propagated in the network and then see who is connected to who. I think, and yeah, and I hope I'll be able to slowly move to Lightning, to like protocol and infrastructure stuff, to some ideas on top of Bitcoin. So there are like, for example, cool stuff I'm interested in is how to. So let's say I have a messenger, but I don't want to verify everybody by SIM card, and I want to protect from bots. I don't want people to abuse my messenger. So instead, I can ask people to prove that they had Bitcoin sometimes before 2017, let's say, but in a private way. So not just commit to a particular UTXO and say, this is my UTXO, I can prove it to you, because that's not private, that's not good, and people won't use it. But if we can find a way to make this private with some zero knowledge proofs, I think this is super cool. And Messenger is just really it's a broader topic of civil defense. So how to prevent somebody from having multiple identities and abusing it, and that can be useful in various ways. You can build a separate peer-to-peer network for Bitcoin where you can allow people only who can prove some ownership. You can solve some issues with coin joins where it's very cheap to Sybil attack coin join. It's very cheap to pretend that you're an honest participant of a coin join while you're a spy, and just overwhelm all the coin joins with spy addresses so that you can infer all the honest people who try to get anonymized. So that's stuff I'm interested in, and I hope I'll have to learn some cryptography. I've been putting that aside for a while, and yeah, I'm excited about that too. With the applications, like applications, it's like I think we're in very early days. I'm glad that some businesses are exploring all this stuff. What really makes sense to me is I think video games and Lightning is super cool. I think the part where you can like do shooter where you shoot somebody and then you collect Satoshi from them because you shoot them. I think that's gonna be a big deal. I don't know,
like Light Night.
Yeah, I would be so happy to play that if I was like, I don't know, 15 or something. And it's like, yeah, it's so trivial, and it can be not decentralized or whatever. It's just much more fun. Like, I don't know, even just simple gambling, like poker or whatever, just over Lightning. I think that's a super cool niche. So I'm looking forward to those. Another application layer is definitely exchanges without KYC. So like hodl or BISC in the States, because like I'm in New York right now and I have hard times buying Bitcoin. I don't want IRS or whatever to like I don't want to have any evidence that I touched Bitcoin at all. And
Right. Yeah.
and there is like no good way to really purchase Bitcoins without KYC right now. And I hope there will be creative solutions like using some gift cards, like this prepaid debit cards. I think that's something I'm looking forward to.
Yeah, so as I understand, I guess there's different things here. There's things like Purse and so on that I think you can do something like that where you put up gift cards and people can pay Bitcoin to, use the gift cards and things like that. And then BISC and HODL and things like that, where obviously you can do cash trades and so on. Obviously, you still have to meet someone in person. That person has to, obviously see you, and that can be a bit more challenging. And then also some of those platforms offer as well, like bank transfer means. But even then, the challenge is dealing with, scamming people and so on. And again, there are countermeasures against these things, but again, nothing's perfect, I guess.
Well, the worst thing for me, like if you talk about bank transfers, you don't know who's on the other side. What if it's some terrorist and you're sending your like transfer to them, and now your bank account is banned forever. They actually freeze your existing funds. Like no matter how much you send, they freeze entire account. Best case, worst case, they put you in jail because you transacted with some terrorists. So that's really what worries me most in these things.
Right, yeah, and I guess it's just not an easy problem to solve. But I guess people can do things like, say, have a bank account open that is only for Bitcoin trades, and use that only to kind of segregate away from the rest of their financial transactions with their normal bank. Maybe that's one way, although imperfect, obviously.
Yeah, assuming first they don't put you in jail, and second,
Yeah.
the taxation agency cannot access your bank transactions, because that's also like not that difficult to trace. It's probably easier to trace than Bitcoin, and uh, yeah, just by looking at who sent whom, and I don't know.
Yeah, of course, of course. I mean, you basically have to assume that those any federal government agency or taxation agency who asks for it will get it, basically. So that you just have to basically assume that. Um, but it's not an easy thing. So what about when you were talking about the CoinJoin stuff and proving that you own bitcoins and so on? Is there any relevance there with Join Market's PODL, proof of I think it's proof of discrete log equivalence?
Yeah, yeah. I was
Yeah, that's what you were referring to.
not quite. I think Poodle works well. First of all, it's much more practical. It doesn't require fancy cryptography. It's a super neat trick. Like it's really cool, but it's nothing. It's like uh, for the stuff I'm talking about, you really need uh, like zero knowledge proofs. Uh, that's so it's funny. I remember this was my impression from learning Poodle. Unfortunately, I don't remember the details of proposal to compare like the actual properties. I can only recall my conclusion. I think Poodle really works only in a uh, Poodle really works only in a very specific CoinJoin like thing.
Right, yeah, and as I understand, some of the Lightning devs are also looking at that as well for things like dual funded channel opening and things like that.
Yeah, that's super cool. Yeah, I'm really hoping to find ways to participate in Lightning more and more, because it seems to get more stable so that it's possible to contribute, and yet a lot of unexplored stuff, and yeah, just good time to be there too.
So, from a Lightning perspective, what are some of your favorite applications or Lightning wallets? I presume you've tried out a bunch of the Lightning wallets.
So actually, I'm just starting with Lightning. It's sort of it was similar with Bitcoin. I think I started to work on Bitcoin before I got excited about the money and the censorship resistance part. I started because it looked like cool research problems, like just something interesting to contribute to, good community, and a lot to learn about in terms of technology and new ideas you can apply. It's the same with Lightning. I'm learning protocol first, and then I will converge to wallets and stuff. I got my first Lightning coins a month ago, or no, I think it's more like 4 months. So do you know this Keybase messenger? And they had
Yeah, yeah.
a stellar airdrop, and they just converted that to Lightning immediately when I got it. That was my first Lightning. And there was, I don't remember the name of the service, but it's somebody in New York that built it. And yeah, I used it. I use Wallet of Satoshi on on iPhone. I think it's custodial, but yeah, whatever. I just wanted my free airdrop Lightning. So yeah, so I'm stuck to that right now. As I said, I will learn more protocol first, and then I'll switch to better tools, I guess.
Yeah, and as you mentioned, you're mostly looking at Rust Lightning right now. Yeah.
That's my application. Well, it's interesting. I was mentioning attacks we found with Anton. So to research those, to see how easy to is to use those, we're actually looking at like LND and neutrino client and async Scala thing. just because those are the most popular right now. So if we want to justify some attack and some countermeasures, we want to look at those. So I'm quite familiar with those code bases too. But as a contributor, I'm started looking at Rustlight, and yeah, I learned a bit of Rust last month, and yeah, just trying to apply my knowledge and learn more on Rustlight now.
And so previously, have you mostly been doing like Python and C++?
Yeah, exactly. Because I was more like researching, so do experiments in Python, just try to simulate the network, because our network is 60,000 nodes, and you cannot have a real like copy of that. So you make a like much simpler Python representation of them, and they talk to each other, and then you measure stuff and just statistics too. And then once I need to make a change to Bitcoin Core, I do C++. Yeah, but I did everything. I didn't do like crazy functional languages. I didn't do Haskell, but I was programming since I was like 12, I think. So it's been more than 10 years now, and I did a lot of not so good, but enough code to get familiar with languages. Yeah.
All right. Well, look, I guess if you got any call outs that you want listeners to consider, or if there's any particular review or support that you want to shout out for, maybe now's the time.
Yeah. Okay. I just wanted to tell our listeners that right now it's really good time to start looking into Bitcoin closer from whatever aspect of it makes you curious. But on my example, I just started contributing so randomly, and it was very smooth. I'm not a perfect programmer. I never was at Google, and I don't know. I think it's so good time to start looking at it on, even if you have a full-time job, on weekends, even if you don't code. I think you can contribute. Amity wrote recently a really good article on how to start contributing to Bitcoin Core. There are all these other projects. You can learn code right away. I'm sure, like if you have some kind of technical education, that's doable. Even if you're not having technical education, you can do it. I have friends who started contributing, at least looking into open source and reviewing code without any prior knowledge. And yeah, I hope more people are joining us in building these cool things.
So Gleb, if listeners want to follow you online or see what you're saying, where can they follow you?
My Twitter handle is Tomato Dread, and yeah, I guess that's it. My DMs are open. I'm always open for research, collaborations, ideas how to make Bitcoin Core or other projects better. I'm open to all sorts of working together. Like I'm super positive about different experiences, and I want to help everybody to get up to speed, to join, and to contribute.
Well, thanks for joining me, Gleb.
Thank you. It was great.
Get the show notes and the transcript at stefanlivera.com/164. Thanks for listening, and I'll see you in the Citadels.